Warm greetings, everyone. On behalf of W4W Foundation, a think tank instituted as Citizens Collective, we welcome you to another session of Wednesdays for Water. The conversation today is titled Geospatial Technologies for Water Resources Management and Wetland Restoration. What a good day it can be when we just had two more Ramsar sites. But before we get into the session, let me just give a brief overview of what we do at Wednesdays for Water. The objective of Wednesdays for Water is to engage in conversation with water experts, grassroots practitioners, policymakers, and youth to explore the complex intertwined issues revolving around water and the possible solutions the people are working on or seeking for. With the success of Wednesdays for Water, we had to expand it to have more activities like Friday Waters, which has water arts, water talkies, water thesis club, water reading club, and Meet a Maestro. Besides appreciating and acknowledging the role of women in the water sector by doing Monday Munching and Musing with Women for Water. These are all online sessions. Having said that, we complement the online sessions with on-site activities, including water workshops, water walks and talks, seminars, special courses, water festival, conference panels, and many more things to make the water conversation happen in any possible way. Do visit our website, www.w4w.in for more details. At W4W, we strongly believe water conversations are crucial for water conservation. This is Mansi Bal Bhargav from the House of W4W and also the host for today's session. And we have with us Dr. Rajkumari Sunita Devi, first as a discussant of the session, but also one of the core team members of W4W as one of the founders. Thank you so much, Sunita, for coming back again and taking charge of this session. Before I let you take charge of the session, I would also like to take this opportunity to introduce you as the speaker of the session. Sunita was a remote sensing and GIS scientist, and slowly she expanded her focus to watershed management and ground level data to action, mostly for water and soil conservation. She is with SNLA for Watershed Management in Manipur, and I know she had really serious responsibility to take care of the Pradhan Mantri's watershed management across Manipur. I will just keep it short for Sunita because she is our, I must say, as in Hindi, we call it Ghar Ki Murki, or our own host. So we'll keep it short for her. And over to you, Sunita. And thank you so much for organizing this wonderful session with Professor Garg and Professor Ajai as speakers of the session. And I request you to take charge of the session. Thanks a lot.
Thank you, Mansi. Thanks for the introduction. But today we have with us two Professor Garg and Professor Ajay. Have known him long time back, and we also have many association with both of them. So I may now invite Professor Garg. He has over 4 decades of wide-ranging professional and administrative experience in research and academic institutes. Professor Garg was also associated as a senior scientist during 1976 to 2008 in Space Application Center ISRO, where I first met him also. And he mostly do the pioneer work for satellite remote sensing for study of wetland ecology, environment, and disasters. He has also globally done research on wetland and has carried out the first scientific inventory of wetlands of India. Beside that, he has an extensive research on the Himalayan wetlands related to the forest, the natural hazards, and many other facets of bioresource and environment. I could also remember that Professor Garg was mainly involved with the bioresources of wetlands. That was the first time, again, more on the methane emission from wetland also. And besides this academic, he has honorary capacity as Vice President for Wetlands International South Asia, a scientific and technical advisory group, the state member of National Mission on Himalayan Studies of Ministry of Environment, Forest and Climate Change, and as South Asia's lead of GOFC goal of NASA Land Use Land Cover Program. Thank you so much, Professor Garg, for taking our time for us to discuss the important subjects. And I would like you to take over and start with your presentation. Dr. Garg, please.
Thank you, Mansi and Sunita both. So I hope my working looks like some problem looks like.
with your presentation?
No, actually.
You have to share the PowerPoint. Yes, it's
Yeah.
Yes, it's visible, sir.
Okay. Good evening, everybody. I am Garg and will be speaking with you on wetlands. As you know, water and life, no two features are more completely describing the planet Earth than anything else. If water is not there, there cannot be life. Now, the problem is that during the last so many years, or maybe 50 years, because of many reasons, wetlands, or sometimes people call them water bodies, which normally include low-lying areas, lakes, ponds, reservoirs, rivers also, and they have undergone serious changes. Uh, they have been degraded. There are two types of definitions, as many of you may be knowing also. Scientific definition and definition which is followed internationally. Scientific definition defines that wetlands are lands transitional between terrestrial and aquatic ecosystems, where the water table is usually at or near the surface of the earth. What it means is that suppose there is a lake, the peripheral area of the lake is uh, wetland. But really speaking, if we have to do that, then we'll not be able to conserve or restore the wetlands. Wetlands are defined by 3H: hydrology, which derives of wetland, hydrophytic vegetation, and hydric soil. Another definition which is followed globally and which is also followed by uh, India is definition given by Ramsar Convention uh, that defines wetlands are submerged or water saturated lands, both natural and man-made, permanent or temporary, with water that is static or flowing, brackish or salt, including areas of marine water, the depth of which does not exceed 6 meters. Now there are various wetland systems, like there may be marine or coastal wetlands, which include coral reefs, estuarine areas like tidal marshes, mangrove swamps, lakes or lacustrine like lakes, riverine wetlands associated with rivers and streams, and palestrine meaning marshy swamps and bogs. Now, Ramsar Convention came into being in 1971, and as of today, there are 172 parties. Actually, I will not go into the detail. India has, as of today, 96 Ramsar sites, and 2 sites have been added only on Saturday this week. World Wetland Day is celebrated every year on 2nd February. This is the day when Ramsar Convention was held in Iran. And I would like to say that in 2023, the theme of World Wetland Day was that it is time for wetland restoration. India has large number of wetlands, and this classification was given by us in 1991-92, according to which there are 22 types of wetlands. 22 types of wetlands, mainly
Excuse me, just
inland
a
and
second. Key
coastal.
participants are requested to please mute, keep themselves on mute. Sorry, sir. So sorry. Please go ahead.
And these, as I said earlier, these may be lakes, oxbow lakes, high altitude wetlands, riverine wetlands like swamps, reservoirs, tanks, ponds, etc. And in coastal wetlands, we have lagoons like Chilka Lake, Pulikat Lake, which are also Ramsar sites. Creeks are there, beaches are there, intertidal mud flats, salt marshes, mangroves like Sundarbans, you may be knowing, and coral reefs, which are there along Andaman, Nicobar, Lakshadweep, and the Gujarat also. Now, wetlands provide us large number of services, ecosystem services, and as you may be knowing, supporting services or basically ecosystem functions like nutrient cycle, etc. They are responsible for providing provisioning services like food, fodder, fuel, etc. and regulating services like flood, water purification, climate moderation, and so on. And cultural services, as you know that Ganga is there and so many other lakes, rivers are also there, which provide us spiritual nature. But all these wetlands are facing threats which are mainly of man-made nature, like urbanization, conversion to agriculture, hydrological alteration, deterioration in water quality, eutrophication or enrichment of nutrients, many invasive species like water hyacinth, etc., and global climate change also is affecting. Now the problem is, as I said earlier, that why should we restore wetlands? Problem is that degraded wetlands are not able to provide their designated ecosystem services, especially in disaster risk reduction and climate change adaptation. And if you see this figure, if there is a good wetland, then its species complexity and all the ecosystem functions will be there. And if the wetlands are degraded, then it will not be possible for the wetland to provide all the ecosystem services. Now, once we are able to restore the wetland, actually there are many attributes of restored wetlands, and restoration is a man-made process. It has to be done by human beings. If we are able to restore the wetlands, then we'll get clean water, and that will also replenish water levels. Other benefits are revitalized biodiversity, carbon storage, because wetlands have plants as well. Protection from the impact of floods and storms. If rivers are there or shallow areas are there, as you know, then they will be able to store water. Development of ecotourism, improved livelihoods, and increased well-being. Now, wetland restoration typically involves wetlands landscape setting, wetlands condition and integrity assessment, planning and design of restoration plan, implementation, monitoring, and adaptation. Now, at this point, I would like to say that without assessment of catchment integrity, integrity of wetland cannot be ascertained. When I talk of integrity of the wetland, what it means is that its hydrological, biological, and other parameters of the wetlands, they are intact. And similarly, for catchment integrity, also nature of the land use, whether it is forested or non-forested, anthropogenic activities, and geophysical setting. If these things are not intact, then it will not be possible to keep the wetlands in good condition or in good health. Now, in recent times, two things have come into existence: wetland integrity and catchment or landscape integrity. All these equations are given. When I talk of wetland integrity, I mentioned earlier that it basically refers to hydrological integrity, biotic integrity, Landscape integrity means within the wetland, what are various habitat types and water quality. And this formula is given, all these things are integrated and this equation is given. Similarly, for catchment also, we have to have landscape integrity or catchment integrity into plane. If these two things are not there, then no wetland can be restored. If we are not able to restore these two integrities, whether it is wetland or landscape or catchment, uh, there cannot be any integrity, or you can say wetland will not be healthy. But the real problem is that globally, people are not talking about this. And whatever we are doing, they are simply, we are not able to. Now, when we restore the wetland, huge quantity of data is required. Data on water, on topography, depth of bathymetry. Ecology is most important. If we are not able to have good quality or good information about the ecological functions, plants, animals, and other things, then wetlands cannot be restored. Similarly, water quality as well.
Professor Garg,
Besides this,
I just want to say that we have to.
yeah. Now, what I want to say is that lot of data is required for management. And as far as remote sensing is concerned, we we have remote sensing in optical, thermal, and microwave region. GIS is there, which integrates, and we get navigation services from the satellite data. On your left side, we have various types of inland wetlands, and qualitatively, we can get information about the turbidity and aquatic vegetation also. So you can see from on the other side, these things are there. Now, to assess the water quality, there are various indices like normalized difference water index, their formula are given, modified normalized difference water index, turbidity index, chlorophyll index, and all these things are very important. If we are not able to map them, then nothing will be done. Then what remote sensing and GIS provides to us? Remote sensing and is a data source, as I said earlier. GIS integrates. Remote sensing helps us in wetland mapping, hydrological studies, vegetation monitoring, biodiversity assessment, threat analysis, and decision support. I will not go into detail because time is not there.
Yes.
And these are some of the examples which we have, the work which we have done when I was in IP University. Through satellite data, we can map turbidity, water quality, aquatic vegetation, and lower side, chlorophyll. And on the right side, you can see Loktak Lake, various from these are there. And lower bottom, thermal data can also be used for study of uh, thermal parameters of the wetland.
So I think, Professor.
It is the last slide. There is no problem. Yeah. Then we have Renuka wetland, that is also a Ramsar site. Using satellite data, we can study fragmentation of the lake catchment like patch, edge, metrics, etc. And using satellite data, we can assess trophic state and short-term, you can say, management plans, like which are the places which have where biological and physical parameters are to be controlled, water holding capacity, and those places where no action is required. So this table gives you that what are the things which are done for restoration, like assessment and planning, hydrology restoration, vegetation recovery, soil and sediment management, biodiversity enhancement, pollution control, monitoring, and adaptive management. We have to keep one thing in mind, that without adaptive management means we have to monitor the implementation plan time and again, so that we can do it. Now, the way forward is that we have to make use of landscape ecological approach for conservation and restoration of wetlands. And still there is a lot of scope for development of metrics and indicators for assessment of health of wetlands and its catchment integrity, inclusion of socio-cultural milieu of the people directly or indirectly dependent on the wetlands. And
So I
we
think
have to keep one thing in mind that
I'll come directly to
stakeholders
the.
are to be involved from the very beginning.
Yeah, we can see that from
And
the slide. So
yeah,
I was.
thanks for your patience. Yeah.
I was thinking like we have like a sort of question. So I'll directly ask now. I could see from the presentation you have mentioned one word about the riparian area. Riparian area. So in most of the policies of wetland restoration or even for water conservation, India lacks the policy on riparian. But I could see from your slide that the word has been mentioned. But it's also high time that India makes a policy on it. So as far as a scientist or as an academic or as a policy maker, have you ever tried talking to the government about conservation of this riparian area of wetlands or any other water bodies?
Actually, if we see
Is there any
that as
policies,
far
I
as
mean?
presently we have Wetland Conservation and Management Rule 2017, which are in place, and they are very important as far as uh, these things are concerned. If we have to manage the wetlands, these rules are very important. And along with this, we have to make use of biodiversity rules also. They are also there.
But does the rule exist? Does the
Yeah.
rule exist for the government of India? That's what we want to know, because we need a rigid and strong policy if we have to conserve this.
Actually, there are wetland conservation and management rules, as I have said. They were enacted in 2017. Earlier in 2010, also they were there. They have laid the legal foundation under the Environmental Protection Act, and it prohibits activities like encroachment, solid waste dumping, and permanent construction within notified wetlands. And it empowers states and union territories to identify, delineate, and notify wetlands via state wetland authorities. In fact, every state has now state wetland authorities, and it mandates, these rules mandates wetland management plan. Every, especially.
May I request to close the PowerPoint, please? Sorry to interrupt.
Okay.
Please close the PowerPoint. Thank you.
Yeah, another, Dr. Garg, another, being in the administration, nowadays the policy on Gati Shakti is taking over. So Gati Shakti, if you are aware that it's mostly on the development of structural assets. And I was thinking like, what has happened to ISRO's role in application? So ISRO's role seems to be taking a backstage in most of the space application. So it was mostly for natural resource management. But now in the government side, the Gati Shakti policy is taking over, and we could see that it focused more on the structures, infrastructures, and less on the natural resources. So in your capacity, are you aware of this policy, and are you in any form to, give a voice about this? What is the role of ISRO now after Gati Shakti?
Gati Shakti came into being through BISEC National,
exactly, yeah,
which is in Gandhinagar, and it laid the foundation of for infrastructure planning, use of Gati Shakti. Now, as far as ISRO is concerned, or these things are concerned, that ISRO provides satellite data through drone portal, also information about land use and other things also. That is very important. And this plays, satellite data plays a very, very important role as far as we are concerned for restoration. If satellite data we are not able to use, then it will be difficult to make any restoration strategy. Because reason being that we have to monitor time and again, and their satellite data is required.
Okay, thank you so much. I think I'll leave some other questions for the other participants here. Now coming to the next speaker of today's session, I would like to invite Professor Ajai, who is a PhD in physics from Allahabad University. He has also served ISRO for more than 4 decades in various capacities as group director, project director, program coordinator, and he's also a professor and emeritus scientist. Dr. Ajai is internationally recognized for his pioneering work on application of space technology for societal benefits more. So again, he was responsible at ISRO for development of space-based geospatial techniques for natural resource management, including water resource, and also for watershed development. He has addressed more on issues such as desertification, which was even a book was released on it, which was internationally very much acclaimed, on land degradation and the Himalayan glaciers. And he has also been a panel of experts at United Nations and European Commissions on the issues related to land degradation. He has represented many times for Asia and India at the United Nations related to works for land degradation and desertification. He was an honorary professor at Gujarat University and Nirma University. And Dr. Ajai has also received several awards, such as UNCCD's GeoLDN Prize 2021, National Geometric Awards for Excellence 2020, Bhaskara Award in 2017, William Dixon West Award in 2016, ISRO's Team Excellence Award in 2008, and Remote Sensing Award in 1997. I could also mention about Dhiru Morarji Memorial Prize in 1988. So, Dr. Ajai, you wear so many different hats, and we are very honored to have you today here. And he will talk on geospatial techniques on water resource management. So, welcome to the Wednesday for Water, and I give you the stage for the session. Over to you, Dr. Ajai.
Thank you, Dr. Sunita, for giving a very nice introduction of myself. I would like to thank Dr. Manusi and Dr. Sunita for providing this opportunity to share my views on water resources management in this forum. So I would like to come directly to the slides. See, as it was told by Professor Garg also that water is life. But what has happened over a period of time, the availability of water has been decreasing, especially for our country. And if you have a look on the water resource scenario of India, we have sufficient rainfall, which is around 1170 millimeters annually, and the precipitative water available from precipitation is 4,000 billion cubic meter. But the utilizable water is only slightly more than 1,000 billion cubic meter. We have a good area under glaciers in the Himalayan. But what is happening that over a period of time, because of certain drivers and causes, the availability of water per capita in our country has been decreasing. It was about 5,200 cubic meter in 1951, and which
May
has
I
been
interrupt?
decreasing.
Sorry, Ajay. I'm
Yes.
interrupting because I assume you are thinking your slides are visible, but we are not seeing your slide. Huh?
You are not seeing the slide?
No, please share it. Yes. Do you want me to share?
Yeah, please share, because I have already shared from here, but it is somehow it is not seen.
No problem. No problem. I'm here. Are you seeing the slide, people?
No, at least
No?
I'm not seeing. Now it is seen.
Okay. So you may present now. I'll just do the presentation mode.
Just keep in the slide
I
mode.
think
Yes.
you were on this slide, if I
Yes,
understand.
yes. Just make in the slide presentation mode. Is it in presentation mode?
I have made it presentation mode, but viewers have to tell me if they see the presentation. Do
No,
you
we
see
can
it in
see
the
it.
presentation?
No.
Yes.
No?
It is not.
Oh.
Okay. Actually, it is not seen on the full screen.
We can see on full screen.
We can see on
Okay. If
Yeah.
you are saying, if others are saying, I have no issue. See, I was talking about the per capita water availability for India of India. It has decreased from 5,200 in 1951 to 1,486 in 21, and it is likely to come down to 1,376 million cubic meter in 2035. See, which is very low. If you see the standard, as per standard, the water availability per capita less than 1,700 cubic meter is is uh, is under stress. Is supposed to be under stress condition. If it is less than 1,000 cubic meter, it is a scarce condition. And in terms of water availability, the India comes at 132 at the global level. Means it is 32 number in terms of the water availability, whereas many countries are having very high amount of water per capita, and the global average is about 7,500 cubic meters. So you can see that the there is a scarcity in water, and that is why a very stringent water management plan, water resources management plan is required. And this is happening because of the increase in the population and also because of the economic development. Because of economic development, the water use in the industrial sector has increased. Because of population, the per capita water availability has come down. The another point which is important to be noted is that over a period of time, the cultivable land per capita in India has decreased from 0.48 in 1951 to just 0.15 in 2001, and it is projected to be 0.08 hectares in 2035. What does it mean? Because if the land availability is less, that means the agriculture intensification is going to take place. Agriculture intensification means taking more crop, giving more input. That means more water is being used. So because of the agriculture intensification, increasing population and economic development, the availability of water is going down. So we need to have a very strict management plan for water resources. Next slide, please. Can you change this slide? Yes. So, as we said that 4,000 cubic meter water is available, but there is a special variability. It varies from the rainfall varies from 100 millimeter in the western Rajasthan to 10,000 millimeter in the area like Cherrapunji. So water availability also varying across the country. Some places it is very less. Sometimes some places it is sufficiently available. Then, as I mentioned, that the per capita water availability is decreasing, and moreover, because of the economic development, and also because of the people's aspiration to lead a better quality of life, the demand is increasing. I have already mentioned about the per capita arable land or agriculture land is decreasing, so requirement of water for irrigation is increasing, and loss of another thing what is happening because of the unsustainable land management practices, the soil erosion in the catchment area has been increasing, and that leads to sedimentation in the reservoir and thereby decreasing in the capacity of the reservoirs and the lakes and ponds. The water capacity is decreasing, so the storage is decreasing. Then the another important thing which is the negative impact of climate change on water resources, which we are facing, and it is going to be very severe in coming years. And because of the use of the fertilizers, industrial chemicals, etc., the pollution of the water body is increasing. So these are some of the very critical core issues which India is facing, and that is where we need to go for a sustainable management plan for water resources. Can you go to the next slide, please? What are the proposed strategies for water resources management? In fact, we had to have separate strategies for surface water, as well as groundwater. They require different strategies. In case of surface water, what the Jal Shakti Ministry has proposed, the in terms of the management strategies, number one is the interlinking of rivers. Second one is regeneration of the rivers, streams, and ponds. Many of the rivers and streams have become dead because of the many reasons, including the encroachment, pollution, etc. Similarly, ponds have been become dead, so they need to be regenerated. Then assessment of surface water resources in terms of quantity and quality. That is the important important information requirement for making a judicial use of water resources. Then creating new surface water bodies by rainwater harvesting. Then reduction of sediment, and as I mentioned that we need to reduce the soil erosion and subsequent sediment flow in the water bodies by taking the appropriate soil and moisture conservation measures, and then desilting and deepening of water bodies. These are related to surface water bodies. And if we talk about groundwater, we need to increase the recharge both in the hard rock areas as well as in the alluvial plain by construction of a sufficient number of harvesting structures so that we can save the rainwater, and recharge the groundwater. Next one, please. Now I come down to the use of satellite in water resources management. In fact, if we have various different kind of satellites, and in case of water resources management, almost all types of satellites are being used globally as well as in our country. We have communication satellites, where the communication satellites are basically used for real-time data transfer from the site, like where the data on surface water or the water level is being connected using the gauge, and through communication satellite they are communicated on real time to their data center where it is analyzed, and this is being used by Central Water Commission in terms of measuring the water level in rivers and reservoirs. Then Earth observation satellites provides the imagery and which are used for making the map, spatial data, creation of spatial data. For any of the actions which I have showed in the previous slide, the information on thematic map like land use, soil, geology, hydrogeomorphology, terrain conditions, they are required in terms of spatial data. That is where EO satellites helps. Then satellite altimeter is another new type of satellite, is where the satellite sends the pulses of the waves, and through measuring the time delay we get the change in the water level, surface water level. There are many satellites available on this. Then navigation and positioning satellite, GPS, they are used for precise positioning of the gauges where the data is being collected to get the position. Then topographic informations are also very much required for making any management plan, and there are satellites which are provides information. Then the last one is the gravimetric satellite, which measures the Earth's gravity, and it is used for monitoring of the groundwater storage changes. Next one, please. Yeah, now I will take a few minutes, 3 minutes on the use of satellite data in water resources development management. As I mentioned that the water is the strategies for water resources management related to surface water. For example, the interlinking of rivers, the catchment area treatment plan for reducing the soil conservation, the soil erosion. We require different thematic maps like the land use, soil, geology, structural geology, then the drainage network, and then the topographic conditions. So all these informations are provided by satellite images, and also the monitoring of the water level and the assessment of the storage in reservoir is now being done. Then, as I mentioned, the catchment area treatment plan for reducing the soil loss or soil erosion, which leads to sedimentation in reservoir. Dr. Sunita is here, who is expert on this, working on the soil watershed development towards the soil conservation, reducing the soil erosion. Then groundwater prospecting map. This is the satellite images are being used here to find out the area, identify area where the likely of the groundwater is more, so that the drilling can be done in those areas and the water can be extracted. Then it is also used for identifying the suitable for site for putting the rainwater harvesting structures to create new surface water bodies, as well as also for the recharge of the groundwater. Then, as I mentioned, the altimeters are being used for monitoring of the water level in reservoir and thereby estimating the change in the level as well as the change in the volume. I also mentioned about the gravimetric satellite, which is used for find out the change in the groundwater storage. These are all being operationally being done. Monitoring impact of water resources on development action. We can also use satellite images to find what kind of impact has taken place because of the actions taken for water resources development. And then also it is used for mapping and monitoring of our frozen water resources in terms of snow and glaciers. Next one, please. Can you change? Yeah, I just to give a glimpse of the how the satellite data is being used for mapping and monitoring of the water bodies. You can see these typical shape. They are all water bodies, but the change. You can see the change in the tone and color. It is because of the depth of the water bodies as well as the sedimentation. You can see very bright here, very dark here. This is very deep water body. This is probably shallow as well as the sedimentation is there. So there, that is how the surface water body is mapped and monitored. Next one, please. Next, yeah. See, I mentioned that satellite images are being used um, for identifying the areas or groundwater prospecting maps. Here, the different indicators are used on the satellite images. They are identified on the satellite images. For example, paleo channels, there is a likelihood of the having groundwater here. Then lineament cross sections, and also the faults and folds and the floodplains. These some of the indicators, and that is how we use these indicators to make a groundwater prospect map from the satellite imagery. Next one, please. Next. Like this kind of map is made where it shows the good prospect of groundwater, moderate to poor, and very poor, so that the drilling is done only in those areas which has a good prospect. Next one. Next one, please. Yeah. The another use of space technology is to identify the suitable site, specifically in the hard rock area where the secondary porosity is to be used for groundwater recharge. For example, the cross section of the streams and dikes here. These are the area where if you put the water harvesting structures here, the recharge will take place. Similarly, the lineament intersections, then the joining of the streams as well as this area that is the alluvial plain or the river base valley fills. That is where we can put the recharge structures and the groundwater recharge will take place. And these indicators are used for making the groundwater, identifying the sites from recharge structure. Next one, please. The third one is the frozen water. So in frozen water, we have snow as well as the glaciers, and the satellite images can be very well used. You can see these are the snow covered areas. We can monitor the snow, map the area, map the snow covered area, and assess that how much snow melt runoff will be there. Next one, please. Next one, please. Yeah. This is how the satellite images are used for mapping and monitoring of the glaciers. You can see this glacier. You can measure, monitor, identify different features of the glaciers like accumulation area. This is the snow line, elevation area, then a snout. One can map, and using these features, the glaciers of the entire Himalaya has been mapped. Likewise, it can be mapped for any area. The details of the Himalayan glacier. Next one, please. Now, after having suggested the plans for management actions to manage actions for the management of water resources. This is also used to monitor to see that whether there is any impact of the management actions or not, implementation actions or not. This I'm showing one or two example here. You can see this one is the picture of 1991 before the water harvesting structures were made in Saurashtra region of Gujarat, and this is after that, I think 2019. You can see the number of this dark blue color. These are number of the water bodies. You can see here, very few are there. Here, because of the creation of new water bodies through making the water harvesting structure, you can see large number of water bodies are seen here. Similarly, you can see more detail here. you can see the water body, and because of the water bodies, new water bodies, the red color is vegetation on the satellite image. You can see that how the red color has increased from here to this because of the availability of water, which has been created by putting the water harvesting structures and harvesting the rainwater. Next one, please. I will just show one more example here. This is again from the arid area of the Jhabua and Dhar of Madhya Pradesh. You can see that 1990 image and 2018 image, before actions implementation, after. You can see a good number of water bodies because of the implementation of the action plans in creating the new surface water bodies. The thing which I wanted to highlight here is you can see this river here. It is totally dried. But here a series of back-to-back check dams have been made. Series of back-to-back check dams have been made using the by identifying the position of the check dams from the geospatial data and satellite data and geospatial techniques. And now you can see the entire river you are seeing in dark blue color. That means the river is almost regenerated. Entire river is having water. So these are some examples which shows that how we can use the satellite images to monitor and find out that see the impact of the implementation actions for the water resources management. Thank you very much. Next one is thanks only. This is what I briefly wanted to present about the use of space technology and geospatial technology for water resources management.
Thank you, Dr. Ajai. Thank you so much. That was short and very useful. And before I pass on the questions round to the participant here, I just have a very quick questions for you, which you can answer it very quickly. And like, you have worked 4 decades in ISRO, and can you tell how has India's space program evolved from the initial phase to the Earth observation right now, to the present stage? I mean, at least up to when you were in ISRO. So how is the evolution?
Okay. I will answer your question in 2 parts. One is how the respect of India and ISRO has increased in the global sector, globally in terms of the space technology. 50 years back, there was a program, very famous program, which is known as SITES, Satellite Instruction Television Experiment, where in that time India was not having any technology knowledge on the space technology, just started. So we requested US for them to provide us the satellites, and which we can communication satellite ATS-6, and that was used for the education in rural areas, for health education, agriculture education, and also for on the water resources, how to manage water resources. And it was done in the 2,400 backward villages in the country. It was a experiment which was really eye-opener at that time. And also the experiment was for justification of the need of the having a space technology or satellites in India. And after 50 years, what has happened? That time we have taken their satellite. Now they have worked with us as a technological partner in NISR, which was recently launched in July, where the satellite has been built jointly by both of us. That is number one. Number two, I will very quickly tell. In 1978-79, the first satellite, remote sensing satellite, Bhaskara 1 was launched, which was having a spatial resolution of 1 kilometer. Just mind it, 1 kilometer. And we, through the journey from 1979 to 2021, Cartosat 3 was launched, which has a spatial resolution of just 25 centimeter. From 1 kilometer to 25 centimeter of journey, we have conducted this journey over a period of, say, around 40-45 years. And today in ISRO, or India is having one of the best satellite in terms of spatial resolution in the world, and also in terms of the spectral resolution. So that is how we have seen the growth of space technology, especially in the context of remote sensing satellites.
Thank you. That was wonderful, Dr. Ajai. And I can say that we have 2 legends with us tonight here, Dr. Ajai and Dr. Garg. And we have also the participants is increasing up to 44. And I leave the session open to any of the participants who have a question from both the speaker. So if any speaker wants from Dr. Garg right now, please throw your questions. take the paucity of time and again the importance of the lessons here, 2 lessons here. Yeah, Mansi?
Yeah, thank you. Thank you, Sunita, for this opportunity. And before I ask question to both the boys, because I just met them recently in Water Festival, I want to share this book that they gave
Yeah.
me, The Captivating Views of India, if you can see it.
Exactly.
And to be honest, I met them in 1999 as a master student.
Wow.
And now when I have this book, I just want to share with all of you that now this book has become a meditation book for me. Whenever I don't feel good, I just look at this book and see how beautiful the country is through this tapestry and landscape. Thank you so much, both the boys, for this wonderful presentation. I have very simple question for you. As a lay person, because that's the idea of Wednesdays for Water, we ask simple questions to difficult people and difficult scientists. So my simple question to you is that when you were showing, that is one for Ajay, when you were showing this beautiful map of Dhar, because I belong to that region, we see how a pre-data helps to intervene in certain way, and we also see a post-data. Right, that gives a very motivating idea that data management is required. Where do we stand in water management today when Niti Aayog tells us that we have more data crisis than water crisis? I mean, this is a statement of Niti Aayog, not mine. So that's one question for you, and I ask JK another question. Pardon me, I'm just treating you as one of the speakers and not really saying you, sir. Pardon me for that. That was a setting I made with you. JK, when you made a very interesting presentation talking about how should we go on doing Ramsar sites, reaching 100 Ramsar site is more important, or really maintaining the few Ramsar sites we have. I bring a concern from Ahmedabad itself because we are from Ahmedabad. When I looked at the whole Ramsar site document, I was taken aback that the document was copy paste of the Nal Sarovar Ramsar document. So just making a Ramsar document will be enough, or there are more reasons for us to really take care? I ask this question with great concern because I have started working on another Ramsar site, which is a transboundary Ramsar site in Germany, Denmark, and Netherlands on Wadden Sea. Is it only number counting, or there is more to it? Both of you have time to think, and we'll take question also from Shweta so that you can answer all of them together.
Thank you, Mansi. So I've been working in water, and I've been working in spatial data for a long time now. I have a team who works for me at RA who does spatial work as well. Question is, how do we get access to some of this ISRO data? Because we are having to recollect the data all the time, and the data should be available to people, just for the people, right?
A very good question, because this book is not available in Amazon and anywhere. I wanted to give to a friend, but it is not available. Thanks, Shweta, for asking this question. Over to you, both the boys. Please take turns to answer them.
Okay. Let me first answer your question, Mansi, about this book. If you want to give your friend, it is very true that these books are not for sale. They are not for sale, so that is why they are not available. But for giving to your friend, I can send you one copy.
Oh, that's not the answer. Thank you so much.
It is not available on sale.
But then I am the privileged citizen of this country. So
Yes, you are. Okay. Now the question asked by the madam about the availability of the data. There are two kinds of data. One is the data which directly comes from satellite after the basic processing. That anybody can get an order by paying, and some of the data are free from National Remote Sensing Center. So that is one thing. Second thing is the information, spatial data, spatial map. So many of the spatial data and spatial map means interpreted map, like land use or the hydrogeomorphology or the wetlands. Some of them are available on the Vedas portal. I don't know whether she is aware about the Vedas portal or not. You can log into the Vedas portal. A quite number of process data is available. And then if you want certain details, you can contact the person whose details are given there. And third point is that, of course, there are certain very high resolution data, which comes under the restrictions as per the the distribution policy of Government of India. So, but they are only for very high resolution data. But up to 1 meter, as far as I understand, up to 1 meter data is freely available. Freely means buying some cost to National Remote Sensing Center.
So some of the information, just following up on that, when we've tried to contact MRSEC, I'm in Maharashtra, so MRSEC is the organization which I would work with to get data. Some data, they point us to a website. I don't remember the name right off my head. But what happens is when you download, it just gives you a map. I don't want a map. I want a shapefile, which I can use to manipulate and put other things around it or represent what I'm working on. So that is a challenge. When you go to websites, yeah.
Yeah, I understood your question. As far as your particular requirement in terms of
manipulate was the not right word. Sorry to say, Sir Ajay. Probably you want to work on it, not manipulate. Sorry to do this correction.
Exactly. And shapefiles are, they are the basic or the backbone of.
It is only jargon of words. That's all.
Yes.
I agree. She wants to work only.
Correct. When I say manipulate means change it so that, it's not in a
according to
negative
your own
way.
requirement, you want to work on that.
Correct, exactly. Yeah, exactly.
So, sir, for this kind of information and specific to Maharashtra, you need to contact Maharashtra Remote Sensing Center, and I don't think they will say we will not be able to give you.
Okay, so again, I mean, Mansi,
we will take other questions first.
You need to contact them directly.
Okay, all right. We'll do that. And Mansi, I'll get to
JK, thank you. JK, will you answer Ramsar question? And also, Ajay, you had a question on that. But I see there are encourage all the participants to please ask questions to these wonderful people, because these are rare opportunities that we get hold of some senior scientists.
And we have participants increasing also.
And that is also quite surprising that people are still joining. And thanks to the popularity of the speakers. JK, would you like to answer the Ramsar site question, please?
Ramsar site, you want to, let me tell you, Mansi, as of today, there are 96 Ramsar sites. Problem is that during the last couple of years, or rather I would say, during the last 10 years, number has increased from roughly 20 to now 96.
Yes.
And our most of Ramsar sites are under Montrex record. Their ecological character, there is a serious problem. We are simply increasing the number. And by next, within next 2-3 years, maybe number increases to 200, not 100, 200. I'm talking.
Wow.
And we will be having maximum number of Ramsar site in the world. And that is another thing. Now the problem is that as far as these Ramsar sites are concerned, there is a serious problem. Most of them are in very bad shape. Even Sunita is there. She stays in Loktak Lake. I was there a couple of months back. Very poor shape. And that is a serious problem. And problem is that most of the time data is not available. And even if data is available, that data is seldom used. Though wetlands have a portal, no other resource is having a portal, except wetlands. But still, quality of our wetlands is very, very serious. Chilka is the only lake where ecological character has been restored. No other Ramsar site, whether it is Kevla Dev or Pulicat or so many other Ramsar sites are there. There is a serious problem.
So my question then will be, are we selecting Ramsar because there is a serious problem there? Because the idea of selecting Ramsar is that it is already of high ecological value, not because it has serious problem. Because when I'm seeing Ramsar sites abroad in Europe, I see they are already secured, protected, high ecosystem value sites with not so much of severe threat as we see in India. So are we changing the criteria of Montrex record, or what is it? Because Montrex record is already a red signal to the wetland.
Yes. Actually, I will give you one example.
Yes.
Couple of years back, there was not a single Ramsar site in Tamil Nadu. Now Tamil Nadu has maximum number of Ramsar sites. 20 sites are there. And that is a serious problem that everybody wants whether data is available or not. Similarly, in Uttar Pradesh also, couple of years back, there was not a single Ramsar site, but now I think that there are 11, 12 of them. Every state is, they want that we should have Ramsar sites so that we can get international recognition. Even in Gujarat, Nurse Rover couple of years back was not a Ramsar site. Now even Thol is there, Vadwan is there. All these things are there. Problem is that we just simply want to increase the number of sites. Let me tell you their ecological character, whether it is Kerala or Sundarban or Loktak or any Ramsar site. There is a serious problem.
So any of the participant has anything more?
We have question in the chat box. Sunita, you may invite and take charge. Huh?
Yeah,
I asked question as participant, to be honest.
Momo, we have one question from him to Dr. Ajay, like to shed some light on satellite altimeter to study water level and challenges and success of working in ungauged regions where its application is needed. So I'm sort of repeating what he's writing. If Momo is there, you can directly ask, and I can see that he is a Manipuri. So I see many Manipuri here, so it's so encouraging.
That means speakers have got popularity till up to Manipur also.
Yes,
I see many Manipuri.
And yeah, it's also a good time that I ask all the Northeast friends from there that if you really know water speakers, Sunita is already getting people, but Sunita comes to West to get people. But we really want more speakers from Northeast, North of India, Andaman, Nicobar, Lakshadweep. If you know anybody, please let us know. We really want to have a good footprint of speakers from all over the country.
The question asked by the on the altimeter. It was on altimeter, Sunita?
Yes, altimeter.
Yeah. Now I want to tell you that there have been so many satellites in the last 20 years, more than 20 years, which had altimeter. For example, InviSat, Jasan 1, 2, and 3. And then our Indian satellite, Saral Altica, also has altimeter. And they are being operationally used in many countries for monitoring of the water level of the reservoir. And
what about some of the challenges and success you have?
Yeah, challenges are there because the data
in
point.
Ungauged regions, yeah.
The problem, the limitation is the resolution in terms of providing information on the surface water, level, the level of the surface water bodies. The resolution has to increase so that you can get high density map, high resolution map of surface water. That is one of the challenge, and which is being addressed by the space communities.
So if we take it as a question from Shweta, she is even asking for Dr. Ajay's phone number. If that can be answered also.
That will be put in the personal space, not here, because that requires his permission. So
yes.
So we are really running out of time. So maybe a quick last question from any.
If anything else is there in the chat box, please take it up for brief answer.
Yes. I will also, let me just check on YouTube. Because if
one question is there to Dr. Ajay, like about Renuka wetland of Himachal Pradesh. What are the challenges of that wetland? I think maybe this will be more answerable by Dr. Ajay.
Challenges on I didn't get. Can you repeat challenges on?
About the condition of Renuka wetland of Himachal Pradesh and what are the challenges of that wetland?
That I think wetland, our Professor Wetland is here. He can tell.
Actually, Renuka is a very important Ramsar site in Himachal Pradesh. Lord Parsuram is associated with this. It is almost a linear structure, as you must have seen in the presentation. It was also there, and its catchment is getting fragmented slowly. Actually, its catchment is forested. And there are many ecological parameters. I don't know whether the person is knowing about this. Porosity is there, patch density is also increasing, fragmentation is also means its ecological character has degraded. And because of this, there is a serious problem of sedimentation in Renuka Lake. If anything more you want from me?
I think I could see that answers the question. Or maybe as a last question, Mansi, I think I'll just take this question from Rupali Yadav, if she wants to ask directly, or she wants to know whether geospatial technology is the best way to study ecosystem services of wetland. So how can we use best?
When we talk of ecosystem services, basically it is the supporting services which are responsible for all other services. Supporting, when I say nutrient cycling, biomass generation, etc. Now, provisioning services are possible. For example, Makhana. Recently you must have heard that in Darbhanga there is a Makhana board has been created. So provisioning services is possible, and directly using satellite data, we can get some information about this thing, provisioning services. Other services will not be able to get. As far as ecosystem services are concerned, they are evaluated in number of ways. For example, if cultural services are there, travel cost method is there. And there are so many types of methods which are there. Provisioning services, there is no problem. We know the quantity. For example, if fishes are there, then we can get the you can say what will be their value and all. But directly using remote sensing, it will not be possible to get, except in some cases like Makhana or Singhada, Rapa, etc. It is possible.
Okay.
Now,
So,
even icornia or water hyacinth, most of the people know now it has become very useful. People are making so many things out of this. You may be knowing, Sunita, in Manipur also.
Yes.
And in Assam also it is happening.
Exactly. So I'll take the last question from Rajendra Dubey. Sir Dubey is also a ISRO scientist. So the question is to Dr. Garg, what is the State Wetlands Authority doing for its restoration? So I think
what is?
Your former colleague is throwing the question to you.
Actually, that is also my question.
I could not make out.
Where are they sitting?
Yeah.
Where are they sitting?
I think when he talk about, when he asking State Wetland Authority, so he must be mentioning about the Gujarat State Wetland, I suppose.
Gujarat Wetland Authority, I am not knowing much because GIR Foundation is the organization which is doing as far as State Wetland Authority is concerned. So I think Bharat Jetwa is there. You may contact him. But most of the statement authorities, they are actually I am associated with Delhi and Haryana, but not much work is being done through them. They will simply say, but whatever is there, it has to be done through them, any conservation and all that kind of thing. But most of state wetland authorities, they are in name only, whether it is Uttar Pradesh. Uttar Pradesh earlier, some Mr. Srivastava was there, I know him. But now I don't know who is the person because they keep on changing every now and then. That is, basically forest department or sometimes even environment department control wetland authority.
Mansi, I have another question coming up. Do we still have time, or do we take this as?
You may take one last question probably, and because I also need time.
Let's make it this the last one
because it's a Veronica is a student. We will really take it. Yes.
So Veronica is from Hyderabad, I suppose, and as a student of environmental geomatics, she wants to know studying mapping and analysis of Mushi River using remote sensing and GIS. Could any of the speaker, Dr. Garg or Dr. Ajai, guide him how to go about Mushi River mapping and analysis? I think
that's a very open question. Really,
exactly.
it cannot be guided in a session.
Yeah, I have heard about this river.
Yeah, but
let me say
Veronica,
something about this. Let me say something.
Sure,
whenever we are studying any river, one is its boundary changing over time. Another is its water quality. Using satellite data and through using field data as well, we can monitor its quality, chlorophyll concentration, as I have shown for Ganga River in my presentation. Satellite data is very important, to study river migration or river, those kind of things. So hydrogeomorphological studies can be done of its catchment as far as the river is concerned. So that's how we can do it.
I will just supplement one. Veronica, you can also do the land use land cover of the catchment area of the river.
Yeah.
So that will really give you the condition if you want to do any change analysis.
Catchment area and its integrity also. Catchment area and integrity.
Yeah.
Usually people get warm up. Usually people are getting warmed up by now, and then they have
it's really running out of time, and people are getting really heated now. So again, we have another one from Rupali. I think Rupali, this will end the thing. So is habitat mapping for avifaunal habitation utilization possible in wetland through GIS and remote sensing? Avifaunal, sir. So is mapping for avifaunal
Fauna directly it is not possible, but within wetland habitats, means there may be some islands or some vegetated areas, they can be mapped. Zoning can be done as far as any wetland is concerned.
It's habitation, yeah, exactly.
Yeah, within wetland habitat, and then we can try to correlate with those habitat types with avifauna, but directly it is not possible.
That brings me to the last question as a child. Sorry, Sunita. Yeah, please go ahead. Yeah.
Because I think only GPS mapping can be done for any faunal, if particular animal is there nowadays. You put GPS in the animal and you can, like tag them. So see there.
So actually every year, this bird survey is done, waterfowl survey is done, through Wetland International South Asia as far as India is concerned. And our friend P.S. Thakkar is there, expert in avifauna. If somebody is there from Gujarat, he can be in touch with him, or I can, through Wetland International, I can get that person associated.
So thank you so much, both the speakers, Dr. Ajai and Dr. Garg. Now I give to Mansi.
Stay around, boys, and thank you so much, Sunita, for organizing this wonderful session. I really felt that we fell short of time, but we have to respect time because these sessions are always good when they are crisp and short and sweet. And it's really nice to hear both of you guys. I had a very burning question which I wish to ask here before we close, but it is open question. You may answer or not. It's one word question. If we do satellite and GIS for all land mapping and images, what is happening? What is the tool that is used to register everything under the water, within the water? What is that?
Okay, within the water you want, basically as far as water is concerned, there are certain parameters like bathymetry is there, water quality is there, biodiversity is there. So most of these things can be measured and quantified using field data. Now, now as Dr. Ajai was telling, that Cartosat 3 satellite has 25 centimeter spatial resolution. So,
Okay. So we need a session on that. Sunita, I already put that seed into you. That is why this question was there. And today it is also an opportunity. I see so many scientists have joined because of these boys who are here, who could bring their friends on board. This is also a request to all of you. If you have something interesting story to tell and you think the youth must hear, this is an open access water education platform. Please come forward and write to us. Our information is in the chat box. And before I let you go, we would like to announce the next week's events, which are as interesting as this week is. Next week on Monday, Munching and Musing with Women for Water on December 22nd, we have two young water crusaders, I must say, Avli Verma and Afreen Fatima, and they will be talking about their emerging profession and how they are maneuvering their life around it. Next, Wednesdays for Water, our signature series, we go into the biodiversity series, which is the longest series running in Wednesdays for Water. Around 15 sessions have already occurred in biodiversity. We are talking about managing Indian biodiversity in changing landscapes. That's on December 24th at 5 p.m. IST. Next Friday, we have book reading session, and that's part of December 26th. And we are talking about a very soft book. I recently met the author 2 months ago, Water Ideas for Life. And all the information is there in the chat box. It will be also available on our website, www.W4W.in. Do stay tuned with us and do join us at our YouTube series, also at our social media handles, and keep talking about water. At W4W, we strongly believe water conversation is so crucial for water conservation unless and until it becomes everybody's business, as the legend Anil Agarwal of CSE used to say. We are not really going to solve the problems of water. We strongly believe that we have to keep talking about water conversation. That makes us one of the longest water conversation ever taken place in the world. More than 400 sessions with touching more than 600 speakers, almost coming to 700 speakers, and touching more than 10,000 participants who have attended our sessions. We are truly grateful to all of them who have made this series possible and meaningful for not only me personally. I have attended all the sessions, but everyone around who really listened to us. Thank you so much, Ajay, JK, for this wonderful insight. We are going to meet in Ahmedabad and have more talkings in person. And thank you, Sunita, for organizing this session. More sessions on us, and more sessions from these boys who are going to bring more speakers for us. I hope you all three of you enjoyed the session. For Sunita, it is homecoming. For Ajay and JK, I'm sure you are going to bring more speakers for us. Thank you so much, all of you.